Algebra 2. Today we're going to look at a couple other methods for factoring. So far in this unit, we have already practiced the greatest common factor method, GCF, and we have done grouping. Those are the two that we were just tested on. In this note video, we're going to look at number 2, method 2, called difference of squares. And we're also going to look at sum or difference of cubes, SOC, DOC. So we're looking at DOS questions and SOC and DOC questions today. Just a quick review, we already have looked at this table in the past. The ones that we have done, you've done GCF. You do GCF on any number of terms in a problem. GCF questions can have any number of terms. We have already completed grouping. Remember, those problems have 4 or more terms. Today, we're going to look at DOS. DOS questions have 2 terms. And we're also going to look at SOC and DOC, and they have 2 terms as well. Okay, so for your notes today, be writing everything down. The first learning target is how to factor using difference of squares. Difference of squares, abbreviated DOS, difference of squares. In order to know what type of problems these are, you have to understand the wording I've used. Remember from the chart I shared with you a second ago that all DOS problems always have 2 terms. So in every single question, that's what you'll be looking for. Difference is a math word we use for minus. So DOS problems will always have minus signs in them. There'll be 1 minus sign. Squares is a math term we use for power of 2. So you'll see on variables, you'll see powers of 2, 4, 6, 8, those types of numbers as the powers on variables. But numbers, they'll be perfect squares. There will be, again, 2 terms with a minus on one of those terms, and both of the terms in your problem will be perfect squares. Now, on the perfect squares, I need you to make a list in your notes. These are numbers that can be raised to the second power, and the answer to them are the numbers that you're going to be looking for in your problem set. I have typed up a list from 1 to the second all the way up to 12 to the second, and then drawn a little arrow here to indicate this list continues forever. It's just I found this to be a good stopping point. Okay, so you need to write down everything in your notes, and keep in mind these numbers are the ones you really are going to be paying attention to. These are the ones you're going to be looking for. So numbers that will appear in DOS problems are 1 and 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and so on. Steps for factoring DOS. Number 1, step 1, is to look for a GCF. Always look for a greatest common factor no matter what type of problem it is. Factoring problem. If it does have a GCF, you are expected to take that out in the first step. Step 2, you are to find the same factors of each term. So in other words, if they give me 25 in my problem, then I'm supposed to factor it by using 5 times 5. Same number. Step 3, factor these problems into 2 binomials. So you will need to be writing down 2 big parentheses for your answers on these. Step 4, you are to use 1 plus sign and 1 minus sign in your answer. And step 5, you are to check your answer with FOIL to see if you get the same problem back. Alright, so again, DOS, there will always be two terms. There will be a minus sign on one of them. Look for numbers that are in this list to appear, and go from there. Number 1, 4x the second minus y to the second. 4x the second minus y to the second. Please notice, obviously there are two terms here. There is a minus sign. Notice the numbers involved are 4 and 1, and since 4 and 1 are both in this list, then and the powers are both 2, this is a classic example of DOS. So we are allowed to follow these steps to find the answer. Step 1, look for a GCF. The only number that will divide into 1 and 4 at the same time is 1. Both of these terms do not have an x, and both do not have a y. So in my example 1, there is no GCF. Step 2, you are to find the same factors of each term. And you're supposed to, I'm going to kind of combine 2 and 3, you're supposed to factor this problem into two binomials. So underneath, you'll draw two sets of parentheses. 4 again is in this list. Since 4 is the same thing as 2 squared, then the factors of 4 are 2 times 2. Also notice this is x to the second. You're going to break that up as factors x to the first times x to the first. Remember from the past, when you are multiplying, you actually are adding powers. Okay, so that's why it's 2x. Okay, next, your job is to look at the 1y to the second. Well, factor that into the same factor, 1 times 1, and then of course the y times the y. And you do not necessarily have to write the 1 as the coefficient. Okay, so I've looked for GCF. I didn't see one. I found the same factors of each term. Please notice these are the same. Factor that into two binomials, have my two parentheses down. Now the directions in my steps say to use one plus sign and one minus sign in my answer. It does not matter what order you write the signs in. Does not matter. Okay, so I performed steps 1 through 4, and now it says for me to check my answer. So I'm going to highlight this. That appears to be what the answer is based on the steps. And now we're going to do a quick check. And by check, I'm going to go all the way through with you for the first one, and then I'm going to show you a little shortcut on the next problem. But for check, you would do first would be 2x times 2x. That would be 4x squared. O stands for outside. You multiply the 2x times the negative 1y. 2 times negative 1 is negative 2. xy is xy. Inside, inside 1y times 2x. Positive 1 times positive 2 is positive 2. Y times x is yx or xy. I always like to write it in alphabetical order. And then the L in FOIL is last. Multiply this term times this term. Positive 1 times negative 1 is negative 1. Y times y is y squared. And what's supposed to happen in the check is once you combine like terms, you should get back the same problem you started with. Okay, so I want you to notice in my check right now that the two terms I'm underlining are the same. They both have xy. One of them has a coefficient of negative 2 and the other has a coefficient of positive 2. Negative 2 plus 2 gives me 0, so those cancel. And then what I'm left with is 4x squared minus 1y squared. So using FOIL to check this will always show you if you have the right answer. And remember, of all this work, the highlighted part right here is the actual answer. Okay, let's try number 2. Here are the things you ask yourself when you're on your own. First, do you see two terms? Yes. Is there a minus sign on one of them? Is the power on the variable a 2 or a 4, 6, 8, something even that you can break apart evenly. Look at 9 and look at 81. Okay, so you're always paying attention to the numbers you have as well. You're checking out your list to see if it appears in those. All right, and then we're going to go back and we're going to follow step 1 in the process. Look for a GCF first. Okay, so since I have to look for a greatest common factor, I'm noticing that on my example 2, both of these have a 9 in common. 9 divides into itself, and it also divides into 81. So example 2 does have a GCF, and you do have to show this step to get full credit. The problem here with the A is this one has a squared and this one does not, so A is not part of the GCF. Okay, so this is going back and doing what we did on our last test. We're going to factor out the 9. You're going to be left with A to the second here. And then minus 9 times negative 9 is 81. All right, after you factor out your GCF, you then are to look at the piece on the inside and ask yourself the same questions. Does it fit the category? Does it have 2 terms? Minus sign in the middle, power of 2, 4, 6, 8 on the variables, and then look at the numbers. We're looking at 1 and we're looking at 9. And those are both in the list. So we continue. We drop this GCF down in the next step and any step below. Always keep that in your answer. You're now going to break the a squared minus 9 up into 2 binomials. To factor it, do the same thing we did over here. Factors of 1a to the second, they have to be the same, are going to be 1a times 1a. Factors of 9, well, 9 is 3 squared, so 3 times 3 is 9. We'll put 3 here and 3 here. And please notice I'm putting it at the end of each parenthesis. And then the rule says, or your steps say, to use 1 plus and 1 minus sign. Again, the order does not matter. And so, based on the steps I've shown, this appears to be the answer. Alright, so let me do this with a check this time. I'll show you a really, a little bit faster way to check it. I always, as long as I'm careful with these numbers, on the FOIL, I always worry more about the OI. Like, to me, that's the most important part of FOIL. And so what I would have you do is, on the check, let's just see if this piece and grab a different color. If this piece and this piece actually give us this back, okay? Because I know we factored out 9 correctly. So instead of checking all of this, let's just check these 2 binomials. And again, I'm going to share with you a little faster way to check it. I would just do the OI. I like to call that the OI part, the OI, to see if this times this and this times this show up here. So 1a times negative 3 is negative 3a. On the inside, positive 3 times 1a is positive 3a. And then if you do want to check the first and put 1a squared here and the last and put minus 9, you're welcome to do that. You can do that in your head as well. I just wanted to show you a faster way to check. So when you check the OI and DOS questions, what should happen is you get the same thing with 1 negative and 1 positive. That's why we use those different signs in the answer. And those should cancel for you. And that's a good thing because in this problem right here, follow my cursor, there is no a to the first term. And so that's what happens in DOS. When you check, the outside and the inside, which is called the OI in FOIL, should cancel for you, and the F and the L should be the remaining part. So to be successful with this learning target, you follow exactly what's on your screen right now, and you start memorizing these perfect squares. I would just go up to 12. Anything higher than that, you can use your calculator on, of course. and then follow my 5-step process. Alright, let's try a couple more. Let's do number 3. Number 3 is 28a to the second minus 7. First thing I always do is check for a GCF. I'm noticing that 7 goes into 7 and 28, so 7 would be a GCF for this one. 7 times 4a to the second is going to give me back what I have. And 7 times a negative 1 will give me the negative 7. Next, I'm going to focus on the binomial on the inside and see if it fits the DOS category. I do see 2 terms. I see a minus sign on one of them. I see a power of 2. And I see the numbers 4 and 1 as coefficients. Again, 1 and 4 are both in my perfect squared list, meaning that this is an example of a DOS. Always bring your GCF down. That is part of your answer. You are now focused on the highlighted part and trying to factor it. Factors of 4a squared are 2a and 2a. Factors of 1 are 1 times 1. There should be 1 plus sign and 1 minus sign. Okay, so based on what I've done, that appears to be the answer. And then a very quick check on the O and the I. 2a times negative 1, kind of jot that down quickly, and 1 times 2a. I have a negative 2a and a positive 2a, which is 0a, and that's a good thing because I don't see a to the first in this problem. So I know my signs are correct. Okay. All right, let's check out number 4. On number 4, I do want you to notice that the minus sign is actually here. When you see questions like this, it might be a good idea for you to turn the problem backwards. Remember, 64 is positive. Put that in front, and then put the minus 4c squared behind it. So you are allowed to change the order if the minus sign is not in the middle. Then you're looking for a common factor. There is a number that goes into 4 and 64. 2 will work, but 4 is actually better. So let's always pick the greatest number. Okay, then you're going to see 4 times something gives you 64. And that's going to be 16. 4 times something gives you negative 4c squared, and that's going to be negative 1c squared. All right, you're going to drop your 4 down. You're then going to pay attention to the inside. It has 2 terms, minus sign. 16 and 1 are both perfect squares, and I see a power of 2 on the variable, so I am going to try to factor this. Factors of 16 are 4 times 4. Again, always make sure you use the same number. Factors of 1c squared are 1c and 1c. And DOS problems, we have a plus sign and we have a minus sign. All of this that I'm highlighting appears to be the answer. Alright, let's check out number 5. Let's do one more like this. We got x to the 4th this time, minus 1. I do see 2 terms. Looking for a GCF, the only number that goes into 1 and 1 is 1. I do not have to show 1 on the outside. It will not change the inside, remember. Both of these do not have an x, so this one appears to not have a GCF. I do notice, again, 2 terms with a minus sign on one of them. I'm liking that I see actually a power of 4 this time. And so remember, to be a perfect square DOS problem, the exponents need to be even. And so this should work. I've got to find factors of x to the 4th to put in the first 2 positions of the parentheses. You're going to split this apart, so it should be 1x to the 2nd times 1x to the 2nd. Again, just making sure you recall from the past, when you are multiplying like the check here, you're doing 1 times 1 is 1, x squared and x squared multiplied together is actually x to the fourth because you add powers when you're multiplying. Then you're finding factors of 1, which are 1 and 1, and then you use 1 plus sign and 1 minus sign. Alright, now the reason I'm doing this one with you is I wanted you to notice that sometimes when we do these types of problems, it didn't happen up here or in this problem or any of the ones we've done so far, but in this question, I need you to focus, really pay attention on this piece. The piece I've highlighted right now has two terms, minus sign on one of them, power is 2, and the numbers 1 are both perfect squares. So this question is not finished. This one has another DOS. There's like 2 DOS questions in this one. Now, refer to the first parentheses. You see that this has a plus sign. That's obviously not a difference or a minus sign, so this cannot be factored any further. So that part, you're just going to get to drop straight down, and don't try to simplify that. That is not a DOS. Then your job is to focus on the highlighted part, recognize that it's another DOS, and it needs to be broken down further into 2 parentheses. Factors of 1x squared are 1x and 1x. Factors of 1 are 1 and 1. And we need 1 plus and 1 minus. And then you check out each parenthesis. I've got 3 binomials right now. The first one, again, does not factor further. This one has a plus sign, will not factor further. This one does have a minus sign, but notice that the power on x is not an even number. Cannot be broken down again, and so because of that, all of this, we're finished. All of this is the final answer. So just be aware that sometimes they can be factored down twice, and look for that. Also remember that if your minus sign's not in the middle, that you are allowed to switch the order and go from there. Okay, so that is a difference of squares type of problem. Start memorizing perfect squares, follow your notes exactly, and then don't forget to check with FOIL, and you can do the quick check and just check the OI.